Hey class, so at the beginning of chapter 8 here, we're going to talk about just the properties of exponents. Okay, this whole chapter we're going to be working with exponents, so that's going to be the focus for this. Okay, so these laws of exponents are ways for us to handle them if you have to multiply them or take a power to a power or things like that. Okay, so this first law here is the product of powers. Okay, so we're taking the product. Remember, product means multiplication, so that's the dot here. Okay, the product of two different things with a power in them. All right, that's what this first one means. Now, pay close attention to this. Probably take some notes on it because these three laws sound very similar. Lots of P's going on in here with O's and things like that, so they seem very similar. So you got to make sure you can distinguish between each of them. All right, so the product of powers property or rule is illustrated with this example right here. So a to the m power, okay, so some constant or variable to the m power times that same constant to a different power, n power. When you have something like that, all you're going to do is you're going to keep that same base, keep your a in the answer, and your exponent is going to be found by adding the two powers that you have. Okay, so a to the m times a to the n equals a to the m plus n. All right, that's illustrated with this example. 5 to the 6th times 5 to the 3rd. Okay, since we have the same base here, all right, your answer is still going to be base 5. All right, and the way we get our powers is we add up those two exponents. So 6 plus 3. Okay, 5 to the 6th plus 3, you can simplify it to 5 to the 9th. Okay, just like that. It's not too complicated, but it gets more difficult when it's easier to mix up the different properties. Okay, the second one is the power to a power property. All right, so this one we've got two different powers here. So you've got just one base, okay, a to the m, okay, but we're going to take that whole a to the m, okay, that's what the parentheses are doing, telling us that we take the whole a to the m and to take that to another exponent, the n power. All right, so that's why it's the power to a power. So if you have a power to a power like that, so the way you'd read this is a to the m to the n power. All right, the way that works is you multiply the exponents. Okay, you keep your base again, but now you're going to multiply those two exponents together. Okay, so rather than up above when we're adding them, now you're going to multiply them. Okay, so in this example, we've got 3 as our base, so it's going to stay. So we got 3 to the 4th to the 2nd power, or 3 to the 4th squared. All right, so the way we're going to get that is by doing 3 to the 4 times 2 power. Okay, and we know that 4 times 2 is 8, so 3 to the 8th would be the answer. And then, of course, because that's a number, you could simplify that and type in your calculator or do 3 times 3 times 3 times 3 8 times, and you can get the actual numeric value. I'm okay with 3 to the 8th when something's that big. Okay? Power of a product property. Okay, so we've got product of powers, power to a power, and now power of a product. Like I said, very confusing if you can't keep them straight. All right, so we're going to start with a product. All right, so you're going to multiply two things on the inside of this, your a times b, and you're going to take the whole thing in parentheses and raise it to a certain power m. So you'd say a times b to the m power. Okay, the quantity of a times b to the m power. All right, when you have something like this, basically what you're going to do is you're going to distribute that m power to both the a and the b. Okay, so the answer is going to be a to the m times b to the m. That's how we get it right there. Okay? There's what it looks like. If we've got 2x cubed, okay, so we get the quantity of 2x cubed, we're going to take this cubed, and we're going to distribute to both of them. So that equals 2 to the 3rd times x to the 3rd. Well, 2 to the 3rd is pretty small. We can do that in our heads. 2 times 2 times 2 is 8. So this is going to end up as 8x to the 3rd, or 8x cubed. All right, let's jump into the examples. So we want to simplify each of these expressions. All right, so this first one, we've got negative 3 cubed times negative 3 times negative 3 to the 5th. So with something like this, right, we see that we have our base negative 3 shared through all of them, so that means we can go ahead and combine them. All right, the 3 and the 5 seem pretty normal, but there's no exponent here for the negative 3 in the middle. Okay, if there's ever no exponent, then the exponent that you assume is 1. Okay, because that just means there's one negative 3. All right, so now we're good to go. We can write our base negative 3. Remember, if there's a negative, you got to have it in parentheses, so we know it's acting just on the 3. Okay, and then we're going to add our exponents, so 3 plus 1 plus 5, which is equal to negative 3 to the 9th power. That's the first one. All right, second one here. All right, you don't have to have necessarily numbers as your base. You could have a variable. So for this one, we've got y as our base. Okay, so since y is the same base for all these, it's going to be the base again, and you add up all the exponents because you're taking the product of some powers. So add all those exponents up. 2 plus 2 plus 4 is 8. And so we've got y to the 8th. Something people confuse a lot. When you see this product, when you see this multiplication sign, a lot of people just try to start multiplying those together. Right? The reason that's going to mess up, right, if you do that, you're going to get 2 times 4 is 4, and 4 times 4 is 16, which is incorrect. Okay, make sure when you're multiplying like that, you're actually adding the exponents. A couple of power to power ones. We got 7 to the 4th to the 5th. Okay, remember, if you get 7 to the 4th to the 5th, you have to multiply the exponents. Okay, so we keep your same base, and you multiply the exponents. 4 times 5, and you've got 7 to the 20th power. Okay, once again, you could get an actual big giant number for that. You don't have to write the giant number. 7 to the 20th works just fine. Now, on this number 4, they're trying to trick you here with a parentheses, and you've got 2 terms in here for your base. All right, so your whole base is n plus 8. Okay, so that doesn't mean that you distribute this squared. You can't distribute a squared in here. You can't distribute that when you're adding them. You can only do that when they're multiplied, like down here, number 5 and number 6. Okay, so because they're adding, you can't distribute that squared. So instead, you just leave the n plus 8 as your base. So n plus 8 is going to stay as our base. Okay, and now we look at what else is going on here. Well, you see this n plus 8 is raised to the power of 2, but then we've got brackets or another set of parentheses around the outside of that, and there's another power raising 2, so that's a power to a power. Remember, for a power to a power, you're going to multiply the exponents together, and so the final answer to this will be n plus 8 quantity to the 18th power. All right, last couple examples. Right here we've got negative 4, or negative quantity, 4mn, all cubed. Okay, now it is important to notice that this negative's on the outside of this. Okay, since the negative's on the outside, that means that you do the third power first, and then we'll throw the negative on the end. Okay, so this is a power of products. All right, power of products. All right, so we actually have 3 products in here. We've got 3 terms that we're multiplying by. All right, so this 3 is going to have to distribute to the n, the m, and the 4. So when we do that, we'll have negative 4 to the 3rd, m to the 3rd, n to the 3rd. Okay, now 4 to the 3rd is kind of big, but we could still do that. I think cubes you can normally do. Okay, 4 to the 3rd is just 4 times 4 times 4, which is 16 times 4, which is 64. Okay, now once we get to the end here, we can just tack that negative on the outside. So we'll have negative, oh, not 16, 64. Whoops. Negative 64, m to the 3rd, n to the 3rd. That's our final answer. Okay, and last problem here. We've got the negative now on the inside, okay, of your parentheses, which means it's attached to just the 2, not the entire quantity like it was up here. Okay, so we're going to take this 4, right, we've got a product on the inside here, multiply negative 2 times g, and we're raising the whole thing to the 4th power, so that means you got to distribute the 4th to both the negative 2 and the g. Right, so it'll look like this. So we've got negative 2 to the 4th power times g to the 4th power. Okay, now we have to do negative 2 to the 4th. For 4th powers, I usually don't have you do those unless it's 2, because 2 is a nice and small number. Okay, so negative 2 to the 4th, remember, is going to be negative 2 times negative 2 times negative 2 times negative 2. Okay, we all know that negative 2 times negative 2 is positive 4, and negative 2 times negative 2 is positive 4. So multiply those two together, and you'll be at positive 16. Okay, so negative 2 to the 4th is positive 16. we've got 16g to the fourth power. And you're all finished.